So what do we do if we encounter this integrand, square root of 2ax minus x squared? So we know for a fact that we cannot use trigonometric substitution directly because it's not in the proper format. And also we cannot use the u substitution right here because it would lead us nowhere, and also we cannot divide it. Of course, there's no denominator. So what I did is, first I completed the square. I rearranged the integrand. The negative x squared would go first, plus 2ax dx. To make it even easier, I factored out the negative sign right here, and it would give me x squared minus 2ax inside. So I completed the square using this simple equation, b over 2 squared is equal to c. This would only be applicable if the term has a positive 1 coefficient. So in this case, negative 2a over 2 would give us negative a. If we square that, we have positive a squared. We redistribute the negative sign so that we would find the counterpart, which we will use in order for it to be the same as this equation right here, because we wouldn't want to alter the values. So negative x squared plus 2ax minus a squared, and the counterpart for this is positive a squared dx. So that would give us the same value as this part. So this is also a perfect square right here, and of course we can put it in this form right here, x minus a squared with a negative right here. So this is already the same for us, this part right here. So a squared minus x squared. So we use x is equal to a sine theta. So for it to exactly look like this one, we use u substitution. So in this case, I designated x minus a as u, and of course d would be just dx. So a squared minus u squared du. So we use this one right here. So u is equal to a sine theta, and sine theta would become u over a, and if we get the arcs, if we get theta alone, that would be arc sine u over a. And since there is a u squared in this integrand right here, we would want to square this part right here. So a sine theta squared would give us a squared sine squared theta du. There's also a d right here, so we just integrate this, would give us a cos theta d theta. Now we substitute what we got right here to this. So we have a squared minus a squared sine squared theta a cos theta, and then there's a common factor a squared right here, so we bring that out. So this would become 1 minus sine squared theta, which is also equivalent to cos squared theta because it's a trigonometric identity. Now we simplify this by just finding the square root of both these terms. A squared square root is a cos squared theta square root cos theta. A cos theta d theta would just be copied, and we would have a final integrand of cos squared theta d theta after bringing out the constants right here, which resulted to a squared. So we neglect a squared for a while and we solve. So cos squared theta d theta wouldn't directly be integrated, so we have to use an identity for this. So it's also equal to cos 2 theta plus 1 over 2 d theta. We integrate this separately, so we have this, and we just bring out the constants here, and we would have this. Now, for this cos 2 theta d theta right here, it would actually be a bother if we have 2 theta right here. So I just substituted another variable for that. So w is equal to 2 theta right here. So if we get theta alone, that would be dw over 2, which would give me this. So this 1/2 right here would also come out 1/4. Then we just integrate cos w, dw would give us sine w. And if we integrate d theta right here, that would be just theta. Now, this would give us the final answer for this particular integrand. So we plugged in this integrand because a while ago we have a squared cos theta d theta. So if we plug in that, it would give us this part, this one right here. If we undo substitution directly, that would actually make our lives it would make solving this even harder. So it would just be simpler later on if we use an identity. But before that, we designate the values for the triangle or the right triangle right here. So since it's sine theta u over a, that would be opposite over hypotenuse. So the opposite would be u, and the hypotenuse would be a. That would be equal to this part right here, these two are basically the same. So once again, I would want this a squared, sine 2 theta to be like, we can find the values right here directly. Would have another identity for that. So sine 2 theta would be 2 sine theta cos theta. So that sine theta would be equal to opposite over hypotenuse, x minus a over a, or u over a. That would be this one. And cos theta would be adjacent over hypotenuse, so that would be this one. So if we just simplify this, cancel a squared, because there are two a's right here, and we have this. And also theta right here is also arc sine u over a, or x over a minus over a right here. So we have this final answer right here.